All right, 6.6. Okay. 6.6 is our lesson today. I know, I have such a beautiful voice. All right, so 6.6, the title, it's today. It's always today. Arithmetic and geometric function. Oh, sequences. Okay. So we do have vocab today. So let's talk about it. The first vocab is sequence. All right, so sequence is an ordered list of numbers that usually forms a pattern. Ordered list of numbers that forms a pattern. Okay. For each number in a sequence is called a term of a sequence. In a sequence, each number has a position. For example, in the sequence below, so I'm going to write that in green because that's usually what our examples look like. We have 3, 7, 11, 15, 19, 23, ... etc., etc., etc. 11, let's look at 11, is the third term. Let's write that down. Oops. Third term. That's term of sequence. And I call it A3 equals 11. The third term equals 11. Okay? So just remember that. All right, next one. Oh my goodness gracious. The next vocab word is arithmetic sequence or math sequence. Okay. So an arithmetic sequence is a sequence where the difference between the consecutive terms is the same. Difference is the same. This is add and subtract. Okay, arithmetic means add and subtract. The sequence above is an arithmetic sequence. So this one is arithmetic because it's going by 3, 4, 5, 6, 7, 4, 7, 8, 9, 10, 11, 4, 11, 12, 13, 14, 15, 4. So you're adding 4 consistently. Or the difference, 7 minus 3. I'm going to put difference or sum because technically it's that. Okay, so the difference is called a common ratio, aka R. Each term is found by multiplying the previous term by... common difference. Oh my gosh, I'm so sorry. I saw the other one. Common difference. Duh. AKA D. I apologize. Much obliged. Oh, no, that's not apologizing. D is your common difference, okay? It totally makes sense because it's D. All right, let's go to the next one. Geometric sequence. Geometric sequence. Okay, and a geometric sequence is where the ratio between the consecutive terms is the same. And this is like multiply and divide. All right, so for example, would be 2, 6, 18, 54, 162, where the A1 would be 2, and the ratio would be 2 times 3. 3. Because every time you multiply by 3, you get that one. And that is called ratio, common ratio, aka R. Okay? So let's talk about geometric sequence. And for this one, A1 is 3. And the difference is, what was it again? 4. All right, it could be positive. Remember, this one is plus or minus. This one is multiply or divide, okay? All right. And the plus or the minus could be negative or positive, FYI. Okay. What am I? Oh, pretzel 1. We'll just make this bigger. Pretzel uno. Okay. State whether each sequence is it arithmetic or geometric? Question mark. And then give the common difference or ratio. And give the value of the fifth, aka A5 term. So it's asking you to do, first, it's going to ask you to do, is it arithmetic or geometric? Give the common ratio or value. Give the common ratio or, I missed something. Difference. Oh my gosh. Oh, it is here. Give the common difference or ratio, and then do the fifth term. So it's literally asking you for 3 things. Okay, 1, 2, 3. All right. So let's look at it. A says 6, 15, 37.5, whoa, 93.75, ... Okay, so I don't see a common 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have my calculator. Where'd it go? Oh, it's up here. Hold on, guys. Let me get my calculator. Okay, so from 6 to 15, the difference is, and I don't need a calculator for that, but 9. And then 37.5 minus 15 is definitely not 9. So there's no common difference, okay? So it must be geometric. That means when you multiply or divide. So what I'm going to do is I'm going to divide these like that. I can do 15 over 6. I can do 37.5 over 15, 93.75 over 37.5. And I'm literally going to do all of them just to make sure. So 15 divided by 6 is 5/2 or 2.5. 37.5 divided by 15, 2.5. And 93.75 divided by 32.7.5. 2.5. Oops. Equals 2.5. So for A, I stated it was geometric. That's the first answer I gave. It is, what was the second? Oh, the common ratio for that one is 2.5. That's my next one, and that was in blue. And the A5. Oh, okay, so do you guys understand? Look, watch this. This is A1, A2, A3, A4. It doesn't have A5. I just multiply the last one by the common ratio to get A5. No biggie. So I'm going to say A5 equals, and then I'm going to get my handy dandy calculator and do 93.75 times 2.5 equals 234.375 is my last thing. So remember, you're supposed to answer 3 things, and I color-coded them to green, blue, purple. All right, B. Oops, I don't want purple on that one. We'll do orange. All right, so this is the next one. I wonder if it's going to be different. 4, comma, 12, comma, 20, comma, 28, comma, dot, dot, dot. Oh my gosh, what could it be? It's an arithmetic sequence. Yay! Okay, so the first one's arithmetic sequence. The common difference, and that was in blue. The common difference is 8. Because you're adding 8 to every one. And A, and that was in purple, yes. And then A to the 5th, because it wants the 5th term, I would just do 28 plus 8. A to that one would be 36. 28, 29, 30, 31, 32, 33, 34, 35, 36. Yep. Perfect. All right. Really quick note. Let's talk about the two graphs. For the arithmetic sequence, just so you know what kind of they look like. I'm sure you already know though, but just FYI. For arithmetic, and then geometric. For arithmetic sequence, your graph would look something like a line. Oops, and most likely it'll be on the first. Let's just talk about the first quadrant. Sorry, I should have done that before. Okay, so most likely it'll look like this. Or like this. And for geometric, it'll look like this. Or like this. Okay? Just so you guys know what kind of it looks like. All right, recursive formula. It sounds scary, but it's not too bad. Recursive. It's recursive. Like cursive. Cursive formula. Relates each term a to the n in a sequence to the previous term. A to the n minus 1. Minus 1 because it's going to the previous term, okay? So there's two ones, obviously, for recursive for arithmetic and recursive for geometric. All right, so recursive formula for arithmetic sequence. Okay. I'll do it, and let's get other colors, you guys. I'll do that pink right there. Actually, that's the same one I had before. Oh, this one's pretty. Okay. Recursive formula for that one. Okay, so it's a to the n. That's always the beginning. A, the previous, so minus 1, plus d. Remember, d was the common difference, okay? A1 is the first term. And d is a common difference. All right. And now we're going to go to the other one. Recursive formula for geometric sequence. Let's do blue, but a different blue. All right, where an equals the common ratio times a minus the previous, where a1 is the first term and r is the common ratio. All right, now that we know that, we can go to pretzel 2. Maybe I'll have room here, we'll see. Pretzel 2. Write a recursive formula for each sequence. Okay, we have an A and a B. A, B. All right, so A is 5, 4.5, so obviously it's going down 4, 3.5, dot, dot, dot. So it is a arithmetic, it's going down by 0.5s every single time. So it's going down by 0.5 every single time, and we're going to use our arithmetic sequence. So it's going to be a to the n. Oops, that looks like a 9. A-n equals, okay, you guys, so a to the n minus 1. Okay, so we have to find a to the n minus 1 is going to stay like that. And then it's going down, so minus 0.5. And then a1 is 5. You have to give them all of this. This is the equation, and you have to state where it starts. Okay? So that's that. And then for geometric, it looks like this. They have 36. And then again, it's going down. Dot, dot, dot. So remember, hold on, sorry. I'm texting. Okay, so remember that it is this over this. So 12 over 36 would give you 1/3. And I'm going to leave it as 1/3. So I'm going to do that one in blue. So a to the n equals 1/3 a n minus 1. And then I have to say a to the first. I'm starting at 36. There, that's it. That's how you write a recursive formula. Oh my gosh, there's another one. Okay, sorry, this one's long. Now we're going to talk about explicit. Explicit formula. All right, explicit formula is another type of equation that can be used to represent sequences using function notation. An explicit formula defines the nth term in the function for the n of any whole number n greater than 0. Recursive formulas require you to show your previous term. Remember the one before? While explicit formula allows you to find any term. Without knowing the previous term. Okay. I think I get that. Just kidding, I'm not sure. But it makes more sense when you do the pretzel. So pretzel 3. Sometimes it makes sense once you find the pretzel. Because when you're hungry, you can't think. So you have to eat to think. Okay. All right, write an explicit. Okay, write an explicit formula for each. Oh, that's a fancy 4. Each. Sequence below. Use the formula to find. Okay, and then use formula to find the 9th term. Oops, that's not enough. It's a T. Okay, I can do that. So the first one says it's arithmetic. And it's telling me the numbers are 6, 11, 16, 21, 26, dot, dot, dot. Okay. So find the value of A1. So A1, make it another color. Where's that green that I was using? That one. A1 equals 6. And the common difference, it's going by 11 minus 6 is 5. Okay. So to write that, I'm going to do f of n equals A1, which is 6, plus the difference is 5 parentheses n minus 1 for the explicit formula. Okay. Did we talk about how to write the explicit? I totally forgot that, you guys. I'm so sorry. Okay. Let me go back. I apologize. Let's see if I can move this down right here. Move this down. I totally forgot to give you the main thing. Okay, let's go back. Okay. So, explicit formula for arithmetic. And explicit formula for geometric. So the way you write this is that A1, which is your first term, plus the common difference n minus 1. And for geometric, you write it as f of n equals the first term times, because it's ratio, the r and then n to the n on that one right there. Okay? All right. Let's do this again. So this is my formula for the first one, arithmetic with parentheses n minus 1. And remember, I want to find the ninth term, so I'm going to sub in 9, okay, to here. Which would give me 8. So 6 plus 5 parentheses 9 minus 1. 6 plus 5 times 8. Order of operations, not PEMDAS. So 6 plus 40 would give me the ninth term would equal 46. Yay. All right. Now this one, B. B says it is geometric. And the numbers are 5, 10, 20, 40, ... All right, so f of n equals, remember my A1 is 5, and it's multiplying by 2. So I'm going to look at my little formula up there. F of n equals 5 times the ratio, which is 2, to the n minus 1. That's my first one formula. And then I do ninth term. So f of n, or f of 9 if you want to write it down, equals 5 times 2 to the 9 minus 1, which is 8 again. And then remember, you have to do order of operations first. So 2 to the 8 and then times 5. So 5 times 2 to the 8 would equal 1,280. Yay. That's it. All right. I'll see you for the, wait, unless there's another one, I'll see you for the review. Okay. Bye.